Здравствуйте. Я доктор Фредерик Жаффрену, и это лекториум. Лекториум. Я говорю по-английски, но документ, проектор — это по-русски. Яндекс транслатор. Мой документ по-английски, говорю по-английски, и Google транслатор, Яндекс транслатор, проектор, видеопроектор. Окей, секунду, потому что так. Я надо стол и так, потому что in same time я говорю. So I turn title about mathematics and humanity, an inseparable alliance for education. So, мини университет это педагогик, университет. So, по-английски хорошо, да? Everybody? So my talk will be about mathematics and humanities, and I want to show that before, from antiquity, mathematics and humanities were together because it comes from the same root, which is philosophy. So я нравится философия. So my talk will have the prism, the light of philosophical point of view. So you have here the title, introduction, and a few citations. The first one from Pythagoras. You know Pythagoras? Yeah, from Scola. Theorem Pythagoras is the most important theorem you've seen, with another one just before, which is Thales theorem. So, and these two theorems of mathematics are very, very important because all mathematics can come from these two theorems, Thales and Pythagoras. So Pythagoras, everything is number. The second one, citation from Galileo Galilei, you know, this Italian from 16th century. Mathematics is a language in which God has written the universe. The third citation from David Hilbert, which is a German mathematician of the 20th century, one of the most important mathematicians of the 20th century. Mathematics is a conceptual system possessing internal necessity that can only be so and by no means otherwise. Inside the introduction, I continued and I wrote, yes, indeed, mathematics is everywhere. From a philosophical perspective of understanding the universe, mathematics is crucial to tell us about how anything behaves. I hope the translation is okay if you, because me, I don't know, so if something you don't understand, you ask me. Mathematics is a core language of natural sciences and engineering. And nowadays is becoming also widely used in social sciences. Social sciences is a part of what we call по-русски humanität. You are student from humanität? All of you from humanität? So don't worry, it will not be about, it will not be big mathematics, donc, but from secondary school. So you know already. Of course, mathematics is in all sciences, all natural sciences, you know, is a language of all natural sciences. Physica, chemistry, biology, so medicine, whole engineering, and from 18th, 19th century, it started to be involved with social sciences, so economic, first, demography, then went to sociology, psychology, almost because of statistics, which is a branch of mathematics. And nowadays, because of computer, spread of computer, I gave a talk last time about digital education. So we have computer everywhere. Every day we need computer with smartphone, tablet, internet. So because of that, informatics came along with social sciences, with humanität. Now you have a camera, and this document is robot, it's translated, Yandex translator, Google translator, and they do that very, very well now. Maybe you can tell me, I don't know. So there is two questions we can say from this topic that I would like to give an answer. And of course, in the title before, you could see the answer of these questions. It's positive, of course. So I will try to show the answers, to develop a little bit the answers. Of course, there is something inside my talk which is common, which is academic, and I also put inside my talk something which is from my own point of view, my own philosophical point of view, and pedagogical point of view. So questions here, the two most questions I will try to give an answer. What are the connections? First, is there some connections? We will see, yes. But what are the connections between mathematics and humanities? And is there a necessary alliance between mathematics and humanities for education? Because we are in pedagogy universität, and you will be destined to go to become preparatori or teachers. So this is important question, because maybe you will have to teach yourself some part of mathematics for maybe elementary pupil, scholar, maybe secondary, or maybe so. But before that, I would like for you to see, so once again the title, and before to go to the development, here. So this is introduction, the title, and before to go to more development, I would like to show you one video you can find on YouTube. It's now famous, very famous video, 4 minutes on YouTube. It has been done of visual by a visual artistic on computer. It's Spanish, Cristobal, and he gave in 4 minutes something very, very synthetical and very complete, a very good insight, a first insight, a very good pedagogic video about mathematics. Well, maybe not, but about why mathematics is important. So I let you looking for the video. I hope there is some sound. Okay, so 4 minutes, and after I will continue the presentation. Of course, also, if you have any questions after, when I finish, of course, we have questions. on YouTube, and you have here the name. You go to Google and you type nature, natur, by numbers. That's all. And then you will have the first video, which is very, very famous. You can see 41,000 people who like very much that. From 2010. Okay, so now we come back to the document. I can close it, this one. Okay. So, so the first part now of the first chapter will be about something you can find everywhere, Wikipedia, it's okay, on a show, even Paluski, about definition and history of mathematics. Well, we have to talk about mathematics, so what is mathematics? Mathematics is talk. So most of the information comes from Wikipedia or Encyclopedia. So the word mathematics comes from ancient Greek language, mathema. So you see, mathema, okay? It's Greek, so maybe you know Greek better than me. Meaning, which is to be learned, or simply science or knowledge. The main school of thought which impregnated, so first of all about the definition, opределение. So the main school of thought which impregnated all Greek civilization, and so all European civilization, and Ruski Europa, was Pythagoreanism, 6th century before Christ. Pythagoras was the first to call himself a philosopher, philosophos, which means the lover of wisdom. And with his disciples, who were known as mathematikoi, he taught that mathematics was essentially the language of what Aristotle would be about 2 centuries after, would later call metaphysica. So metaphysica is a word that has been invented by Aristotle for the specific topic, which is, as we know, metaphysics. That means above whole, above everything which is related to physica, nature. So the things which are almost invisible, but which are the cause of everything we can see and everything we live in. From the Roman Empire period until around 1500, so 16th century, the term mathematics more commonly meant astrology than astronomy, because many astrologer people and astronomers later, they used mathematics, well, geometry and some calculations. And in we will see after, in history, in Babylonia, the pyramid, ziggurat, but also in Egypt, they used extremely precise mathematics. Then the meaning of mathematics changed to what we understand now to be mathematics from the 18th century, with a huge development of mathematics. So, but let's come back to the 4th century before Christ. Aristotle defined mathematics as a science of quantity. But it was before, because with the development of mathematics, we can have nowadays another definition of mathematics. Well, this definition prevailed. Okay. This definition of Aristotle about the science of quantity prevailed until the 18th century. However, according also to the theory of knowledge of the psychologist Professor Jean Piaget, the Swiss psychologist, one of the very important psychologist, professor, about development, about the theory of knowledge, so epistemology, and who contributed a lot to the psychology for education, the psychology of the pupils, the young students, of children, and the theory of knowledge by the children. How can they know something? How can they understand their development? You can see on internet, Wikipedia, information about Professor Jean-Pierre is very important about epistemology and about psychology. The development of mathematics, he said, can be seen as an ever-increasing series of abstraction. So abstract means you have something which is you can see, you can hear, you can touch from the senses, and then you have a representation of this which is synthetic and more general, abstract. So nowadays, we can define mathematics as a science of relation between abstract structure or abstract entity or abstract objects. But the word important is relation. It's not only counting, no, it's not only geometry. No. Before that, it's relation. The children, the first time you see one yablaka, and he sees a second yablaka, he will compare the two yablaka. If they are the same, he will have the notion, it is the same. So, adin, the same, isho, so dva, etc. Professor Jean Piaget explained that very, very well. So I recommend you to read Professor Jean Piaget, Paruski, because his work was in 1968, 67, before also. And it's about, at that time there was structuralism philosophy, but I think it's very, very important. So now history of mathematics. Here again very academic, so you can find there everywhere. Historia. Prehistoric artifacts show first quantification of time based on lunar calendar, as well as first geometrical figures reproducing astronomical features associated to astrological symbols. We have seen the first to see that was in Europe, not in China, not in Africa, not in Babylonia, but it was in Europe. We have is the first artifact that we can see. Maybe there exist other more ancient we have not yet discovered, but the first we have, it was in 2010. They discovered that in Germany. So it dates from more than about the artifact has been found in Germany about 5,000 years before Christ, something like that. But now, the evidence we have document about application of mathematics, little bit more complex than simple. It's not simple. It's, even Aborigine in Australia, they have even Dogon people in Africa. We have the document that they have symbolon, very, very profound about astronomy, about astrology, and how to represent this in their own culture. But application of mathematics and little bit more complex appear around 3000 before Christ. It's Babylonia and Egypt. Began using arithmetic, algebra, and geometry for taxation, so finance, calculations, as well as for building, so architecture and construction, bridge, everything, and of course pyramid. And for astronomy, astrology was very, very extremely important. Even with the Aztec, the Maya. The Babylonians also used the sexagesimal numeral system based on the base 60, still in use today for measuring angles and time. 60 seconds, 60 minutes. Adin Shastra. Beginning in the 6th century before Christ, извини, пожалуйста, так, I have to be in tune, это хорошо, так, 6th century before Christ, так, секунд, okay, так, okay, I hope you understand. Beginning in the 6th century before Christ with the Pythagoreans. So now it become it become now the study of mathematics for itself. The ancient Greeks were the first to perform a systematic study of mathematics. Rigorous arguments, here, rigorous arguments also first appeared, most notably when Euclid, so you have heard about him. So very important mathematician. The first, we can say, Pythagoras. But Pythagoras was still was the creator of many things which are related to more philosophical. Euclid was completely what today we call mathematician. Euclid introduced in his textbook element. So this for you, element is everything you learn in school about geometry on the plan and on space, 3 dimensions. In 4th century before Christ, the axiomatic method still in use in mathematics today. Then it has become customary to view mathematical research as establishing truth. So definition of mathematics, what is mathematics, is to establish truth by rigorous deduction from appropriately chosen axioms and definitions. As I said, for instance, physics and chemistry, all natural science is about to be precise, to be the precision, to be precise. But mathematics is not about to be precise. Mathematics is about to be exact. You see the difference. So I continue. So then, about the Middle Ages, the Hindu-Arabic numeral system, because number 0 comes from Hindu metaphysics. The Hindu-Arabic numeral system and the rules and the Arabs, when they went to India and converted to Islam by force, when the Crusades, there was some exchange of ideas about and culture normally, because the people were very close. It was the same in Russia with Mongol and Tatar. The Indo-Arabic numeral system and the rules for the use of its operation were then also transmitted to the Western world during the Middle Ages. Then, from the 17th century, there was an explosion of for mathematics. The development of calculus by Newton and Leibniz, what we call infinite calculus. In the 17th century, revolutionized mathematics. Leonhard Euler, his grave is in St. Petersburg. Was known is a Swiss origin. Leonhard Euler was known as the most notable mathematician of the 18th century, contributing numerous theorems and discoveries. And perhaps the foremost mathematician of the 19th century was Carl Friedrich Gauss, who is a German, Prussian, who made numerous contributions to the different fields of mathematics. Then, in the 20th century, Kurt Gödel, Österreich, transformed mathematics by making an immense impact upon logical and philosophical thinking, especially about logic. Very, very important. Especially now, today, about artificial intelligence. He proved that a machine can never solve some problems. Anyway. So, maybe lectorium in May about this. Well, now about aesthetics and philosophy. So now about more interaction between mathematics and humanité, or something in common. Aesthetic, so beauty, art, fine art, and philosophy. One of the most disputed philosophical problems nowadays is to know whether mathematics is created, so constructed, or discovered. Many mathematicians have the opinion that the doing of mathematics is closer to discovery than invention. And with also many philosophers, they think that to call mathematics a science is to downplay the importance of its aesthetic side. Aesthetic storon. Indeed, these mathematicians relate the feeling of understanding of a theorem of mathematics to that of the contemplation of a masterpiece of art. Eureka. Well, Eureka was Archimedes, and he was more physical, but it was, he was mathematician. Artists have always also used mathematics in painting, sculpture, architecture, in music. Some say dancing, ballet, Francia, I read that, by using proportion and perspective, the architecture, symmetry and harmony. Yes, in the video you could see numbers, maybe just la première, you remember the numbers, eta dul, potom adin, da? Eta nul plus adin, eta adin. Adin, so tak, tak, tak. Adin plus adin, eta dva. Dva plus adin, eta tri. Tri plus dva, eta piast. So you remember this sequence. So eta nul, so adin. Adin plus nul, eta adin. Adin, so one number and before the last. You add, so you have one number, and then start again, behind, one again, behind, etc. So you have 3 piast, piast plus 3 это 8, 8 plus piast 13, да? Etc. Да? Я ж по чуть-чуть. Хорошо? This is Fibonacci. Fibonacci sequence. Это Italian, but 13th century, 13th century. But he did not invent. He discovered. But before, it's not him. He put his name, but he read that before they knew that. It's everywhere. You could see construction of crab, doma, in your body, the symmetry, your spinal, your everything. And if the genetic change little bit, you become very ugly. Beauty, symmetry. Not like Picasso. Picasso, he wrote in letter, I want to destroy. So he broke the symmetry. Modern art. But Leonardo da Vinci, he used that to make Mona Lisa, to make perfect. In 1 century after, maybe in 20 years, Picasso, maybe, yeah, I'm sure, because people will wake up. And so Fibonacci sequence everywhere, DNA, everywhere. This compared to this, it gives the number. This is called golden ratio. You can find Wikipedia, and golden ratio was also in the video there. And they knew that in antiquity, Parthenon, Athens, Egypt, pyramid, the number P, it's extraordinary. They put robot inside the gallery of pyramid with laser, and the distance is about less than micrometer. Today, engineers said we don't have technology to do that. So how can it? Mystery. Painting, Leonardo da Vinci is the most well example. Sculpture, architecture, musica, Pythagoras invented I don't know, we will speak a little bit about 2 over 3 when you do guitar ding and you have the fifth and you go красиво, symmetry, harmony, golden ratio, Fibonacci numbers. Da? Okay. Descriptive geometry. It's like a code, and you have kino, film. You can see internet streaming for free. The wood is a contact. It's about maybe some people have seen this. I forgot the name of this actor. They are the SETI program, Amerikanski, of course American, to receive extraterrestrial ET signal. And one day there is a boom, boom, boom. It's prime numbers, and then they have a code, and they build machine to contact. But here, this is like, it's a code. You can programming. The question is, кто программа? Потому что by random, mathematicians calculated by random to have вода molecule. It's вода molecule, it's abnormal molecule. Потому что it's normally these two oxygen, one oxygen, two hydrogen, they to bind together, to have the characteristic of water, the property is it's how to say, to match together these atoms to form this molecule of water, water. It's above the chance. It's absolutely abnormal. Normally, these atoms should not stay in contact. They should not form one molecule. You can see documents, you can see internet, not chemistry, but it's like it is in perpetual instability. That's why just 1 degree temperature, boom, it changes. It's very, very elastic. So it must be very unstable, but also very stable. It's like Debussy ballet on tack, and it's the same. We call that moment of inertia moment, and it's absolutely extraordinary and abnormal. Life is abnormal. We calculated the probability for even complex macromolecule in all the universe. It's above the number of atoms, so it's absolutely abnormal. There was a very good document about this probability calculus of to obtain simple molecule. So yes, Fibonacci numbers, descriptive geometry, so it is used in architecture, very important, and fractal. So fractal is also very important because fractal is everywhere, or pulmon, or skeleton, or everything. Fractal is from one thing you repeat, repeat. And here, by numbers, fractal is geometry, and so you have geometry and you have arithmetic numbers, and it's exactly, it's like another language for the same thing. And so it's absolutely everywhere. And now one of the most famous examples cited to show the beauty of mathematics is certainly, so you have seen one video, I think it's beautiful, the flower, you can count the number of petals of flower. There's only a certain number of petals can be obtained, always. So the most famous example cited to show the beauty of mathematics is certainly Leonhard Euler, identity. This is this formula, this equation. Почему is the most beautiful, everybody, why? Почему? Потому что you have the most important numbers in very malinka. You have exponent. You have E, imaginary, complex. You have P, and you have adding. And you have exponentiation, multiplication, and plus, et null. So you have, in very short, you have most important numbers. A formula which the physicist Richard Feynman, very important American physicist of 20th century, he died in 80s, I think, or 90s, 1990, called our jewel and the most remarkable formula in mathematics. The mathematician, Hungarian Hebrei, mathematician Pavel Erdős, tak, was well known for his notion of an imaginary book in which God has written down all the most beautiful mathematical proofs. He said when he did many articles and proofs, he said, "Oh, this proof is beautiful. It comes from the book, Kniga." In Plato's philosophy, there were two worlds: the physical one in which we live, and another abstract world which contained unchanging truths, including mathematics. Plato believed that the physical world, and Socrates, Plato was a disciple of Socrates, believed that the physical world was a mere reflection of the more perfect abstract world, you know, the allegory of cavern, of grave. Today, French philosopher Alain Badiou claims that ontologie est un mathématique. Badiou also believes in deep connections between mathematics, poetry, and philosophy. Indeed, mathematics is essential in many fields, including natural sciences, engineering, medicine, finance, social sciences. Therefore, some teachers prefer to use various objects to present mathematics in a pleasing way, so for you, for future teachers, in order to help students to gain a conceptual understanding that might not be seen immediately in written mathematical formula. For example, origami, you know, the Japanese Nippon after paper folding has aesthetic qualities as well as many mathematical connections for theory of folding in mathematics, geometry. Another aspect of humanities concerning mathematics is the views of mathematicians towards the possible use of mathematics for purpose deemed unethical. Indeed, in the book of the mathematician Godfrey Harold Hardy, it's an English mathematician of 20th century, the first half 20th century. He worked with Ramanujan, Indian mathematician. There was a movie about them recently. The name of the book is A Mathematician's Apology, in 1940. Hardy argues that pure mathematics, which is mathematics for its own sake, without having any application in mind, is superior in beauty to applied mathematics, precisely because, according to him, pure mathematics cannot be used for war. Indeed, applied mathematics is to build engineering, so ballistic, so rocket, and Russia is very good for rocket, better than Americans today. Zircon recently. So, but it is applied mathematics. However, my reflection, pure mathematics has not only led to entirely new mathematical disciplines, but also to practical applications, like in cryptography. It comes from number theory. Number theory is a pure mathematical number, no ballistic immediately, and cryptography is used in Wojnę, Baron, Enigma, the movie about Alan Turing, Enigma machine, decoding Enigma machine, then the Unterseeboot, U-boat, German attack, and then they could win the war also. Cryptography is based on number theory. So Hardy said there is no pure mathematics have no application to what? No cryptography. Or il racket, which needs the highest precision given by infinite calculus. Well, infinite calculus was from Leibniz, Newton, based on also mechanical, Galilei, and astronomy. But infinite calculus is from Taylor, Englishman, mathematician Taylor. It was absolutely pure mathematics. It's something based on like internal mathematics. Finally, so this is also my my remark, and maybe it's a little bit strange for you. I don't know. I give you. Finally, the philosophical background related to the concepts of matter and space, which led to the revolutionary statement of the Newtonian physics, Newton, 17th century, had still much in common to the Aristotelian philosophy and scholastic theology. But yes, because Newton, he had for the first time about this law of mechanique, first law of mechanique, the force, notion of force, coming from acceleration, so the law of motion. But all of these ideas, mathematical ideas, come from philosophical background of space and matter. What is a space? So for him, space is absolute. God created space, so it's absolute. So it has this notion coming from Aristotle, and it was in the Middle Ages in the Scholastica, Thomas Aquinas. We will see after in Thomas Aquinas' philosophy. We will see after. So it comes from a philosophical background. And I added, if we continue in the same development, nowadays, here, nowadays some scientists, and I believe too, that modern experimentations in high particle physics could lead soon to surprising discoveries regarding, in the antiquity, they call the fifth element. You know, in the antiquity they have what they call the four elements. So it's material, tak, potom voda, water, potom air, gas, and potom fire. And we know that fire in physics from Maxwell is related to electromagnetism. But they said also whole of this matter is inside something more important called the fifth element. They call it etern. And Maxwell, which gives electromagnetic waves, electricity, he believed about this. And Einstein said, "Niet," because it was not good for his theory. And there was an experiment which proved that we don't need etern for light. The problem is light is only one chut visible light from the sun, chut about whole the spectrum of electromagnetic waves, and about whole frequency from radar, from electricity, from infrared, ultraviolet, and UV, and nuclear wave, alpha, beta, nuclear. So maybe for the other it's important and nada. And indeed in the CERN, in the high particle physics, maybe you have seen the movie about the Da Vinci Code, and the second about the CERN, cyclotron, very in Swiss, in France, European. So there are two particles with high speed energy to break, and inside they look inside what's happened. And it could be dangerous also, because we are breaking the very first parts of the universe. And then some scientists believe then we need something which contains everything, which is called the fifth element. We will see. So now the second chapter. So the second chapter will be premiere example. okay, about what I want to express. I hope I take too much time. So, mathematics and humanities. So my answer to the question of first question of introduction, an alliance for a complete and efficient education. And I say like two legs. If you want to walk, you need two legs, not talk. So this is called the classical education. So look at the classical education. That means for me traditional education, not France today they use for kinder they use syllabic, and it's not good because the children because me I learned with A B C D you also, but now they have modèles pédagogiques pseudo-intellectuali, and the psychology say, oh, yet no good, it's not good because it destroys the children. They learn alphabet tag and Cyrillic alphabet tag, but now it is syllabic, so it destroys the ability for the pupils, for the children, to express themselves, and they are very bad in orthograph nowadays, and it's a catastrophe we have in France. So, but the classical education, the people, I remember my grandfather, my grandmother, my grandmother, no, because she had to go to the farm, but the grandfather, they had to go to school, but only elementary school, because they were poor, and they have to work, but he knew very well how to write and everything. But today, people in France who are in baccalaureate, université, they make, the young students, they make big mistakes and errors about orthography. So because it's coming from the pedagogical problem of teaching. One of the most beautiful aspects of mathematics is its relation to the human soul and mind. It is unfortunate that mathematics is seen with so much negativity by many. If you love humanities and do not like mathematics, the reason most likely lies on the way your teachers taught mathematics in school, maybe. Indeed, most teachers don't know how to connect humanities to mathematical thought. Most of them don't see the common philosophical background in either side. However, when we talk, for instance, about human necessity or is it okay? You can understand? It's okay now. When we talk, for instance, about human necessity or possibility in philosophy, we are also talking about mathematical concepts in logics. Similarly, when we think of justice in the society, so I take the premiere of the notion of justice. It's humanité, anthropology. It's very human. It's not a robot. So it's not about calculation. No, it's human. It's emotional. But we are also thinking about, similarly, when we think of justice in the society we live in, we may not realize that our human conception of justice have mathematical counterparts. Почему? The purpose of this talk is therefore to give a little insight about how to build a bridge between such apparently different worlds than humanities and mathematics. The example I choose to present here is about the mathematical mean. So it's the most, very elementary. The first thing we learn at school is the mean. I go to supermarket, на магнит, на креп, это, I don't know, 1 килограмм креп. 1 килограмм это сколько рублей так далее. Я хочу half, so хочу or maybe 1/10, so 100 килограмм, 100 грамм. So 1 килограмм это 30 грамм. So I have to divide by 10. It's the first, everybody, every day we do this ratio. And so the mean is half, the average. But we will see there are 3 important means. From Pythagoras, and they are related to philosophy and humanität, and we will see that. So, the three classical Pythagorean means, which are the arithmetic mean, the first one, the most common mean we know, but also, so we will see, it is a sum of collection of numbers divided by the count of numbers in this collection. We will see just after. Then you have the geometric mean, so Jm, Am, Rm is arithmetic mean, Jm is geometric mean. It's logarithm, the logarithm of geometric mean is the arithmetic mean of the logarithm of each number in the collection. We will see after. And the harmonic mean, Hm, is the inverse of the arithmetic mean of the inverses of each number in the collection. We will see now. We will see now. These three mathematical means are used in almost every sciences. Are used in most every sciences, forming the core of statistical analysis today, applied for instance in economy with the Gini coefficient, which measure the inequality among levels of income. So it's very, very important. It's a very simple formula in economics based on the third formula, this one. And Gini coefficient is today used in high levels in country to check the inequality and to solve the inequality, if they want, because most of the people, most of the time, for some political reasons, like in France today, there was a yellow vest because everybody can see in the law that they prefer oligarchy than. So, well, in Soviet Union it was the same with maybe not oligarchy but apparatchiki. They have their own Magnet magazine for them. They have so on. État communiste, huh? But in communism, Marx said what? There is always the same problem. Because État communiste is not that well, it's a problem for natural economy. So here, na première, Rm is arithmetic mean. Is mean, you know, you take everything, you divide by the number of things. As I said, is 1 over n is x1, so you have n element, I don't know, let's say shoes, da? So you have x1 is one shoe, xn is another shoe, so you have n shoes, and you have any shoes have a proper value, skolko ruble for one shoe, and then you have the arithmetic average, the average for this. Now, the geometric mean, you take first this is a geometric mean formula, but it comes from here. The log of the geometric mean is the arithmetic mean of the log of all the external. Then after calculation, I don't do, using exponentiation, you find the result. Geometric mean of is so root square about the power n of the multiplication. And now you have Hm. You have the harmonic mean. And this is the inverse. So minus adin power means the inverse. It's 1 over 6. And so you obtain this formula, which is used for the Gini coefficient, extraordinary, and it's very, very interestingly used in economy. So, but don't worry, we don't do. So, this is a topic usually taught to pupils during the secondary school. This is elementary statistics. So, secondary school. But I want to show here that the teacher can also give the possibility to the student, through mathematics, to think about different concepts which traditionally belong to the sphere of humanities. For instance, the concept of justice in moral philosophy, which is certainly the most praised concept in politics and economy, Gini coefficient, no? And that can be analyzed in terms of quantitative justice. Or the concept of beauty in aesthetics, that is widely appealed in the different artistic activities. We will see that Pythagoras with an example, la première patron. Then we can understand that this opposition between mathematics and humanities, and roughly speaking between art science, natural sciences, and soft science, eta humanitet, it is today the language in modern pedagogy, hard science and soft science, should be replaced by a collaboration in education. Collaboration, alliance. Why? Indeed, mathematics and humanities are like two legs which make the student to walk confidently on the way towards a complete and efficient education. Since the antiquity, so this is classical education. Since the antiquity, apart from the required basic religious and philosophical studies, an efficient classical education always exposed all the pupils, of course with different levels, but all the pupils from the beginning, at least from the beginning of secondary school, to the famous, so Latin, trivium of the humanities, trivium, three, grammar, logic, and rhetoric, how to express yourself, in coordination with the quadrivium, chitri, in mathematics, arithmetic, geometry, music. It was a part of mathematics, music, because Pythagoras, music, this, there is proportions, and astronomy. So now, la première, we come back to the three Pythagorean mean. Arithmetic, so the first one, AM, arithmetic mean. I want to see you an application of this. So we will do little bit mathematics, but very, very, very simple. Давайте. Let us take two numbers, say 1 и 9. And let us take from Aristotle the categories, so philosophy categories of Aristotelian. Quantity, eta Greek puson, my pronunciation, and the space, pun, maybe, pun. So that we have two categories, quantity and place. So that a number is to be understood as an amount of place. A number, 3, 3 places. We assume also for granted the concept of justice from Aristotle. We assume also for granted the concept of justice from Aristotle, according to which justice is a medium term between what is inferior and what is superior. Medium, so half. And here is Thomas Aquinas, which exposed Aristotle's philosophy about this concept. But equality really is a medium term between the greater and the smaller, as in told in book 10 of Aristotle, Metaphysics, whence justice comprises a real medium term, summa theologia. Then, so la première, between Adin and David. So the middle term will be, we call it M, medium, okay? So we want to calculate what is this number, M, what is the place, amount. The number that equilibrates Adin and David is the one which divides the spatial place, quantity, the two categories, between them in a quantitatively equal manner. the spatial quantity between adin and dievit is a distance. Dievit minus adin. Eta vocem. The spatial quantity between adin and dievit is divided equally into two smaller spatial quantities. The smaller spatial quantity on the left of second. Tac. Okay. Okay. On the left here. Okay. On the left here. The smaller spatial quantity on the left will be given to the smaller number adin. So it's like a balance, and we give this spatial to adin, and on the right will be taken, not given, but taken from the. This is how they understood before. It's not today. Today we make the calculation, but behind calculation there was because calculation comes from something. So and so for education, for the children, me when I was a student, I took money for supporting giving some courses to students in college. So I had to explain. It's not easy. It's not easy to explain. Because for me, yes, but почему? So, whereas the smaller spatial quantity on the right will be taken from the bigger number. So we take from the bigger number, from oligarchy, and we give to the poor number. In this case, justice requires that the medium term m is such that the quantity m minus adin between adin and the medium term m is equal to the quantity dievit minus m between the medium term m and dievit. Therefore, m minus adin equal dievit minus m. If we solve this equation for n, we get result. This is the arithmetic mean. So, and this is exactly correspond in the general a plus b of divided by 2. So that means now if you come back to the definition of the formula arithmetic mean, you remember n, the number here is to ab, so 2, it's 1/2, and sum x adin plus x bar. So that means a plus b divided by 2. It's exactly the formula. Okay? But the formula comes from that. Okay, here. Okay, according to okay, okay. According to Thomas Aquinas, the philosopher Aristotle says in book 5 of Nicomachean Ethics, so a very important letter of Nicomachean. Everything that is superfluous in these things pertinent to justice are called, by extension, profit, as well as everything that is less is called damage. Thomas Aquinas. Justice corrects excess and privation. Likewise, the arithmetic mean corrects excessiveness of dievit over adin by means of redistribution according to quantitative equality. Now, another mean will be different, and that will give a different formula, harmonic mean. And this is very, you will see, me, I didn't know all of this before. I'm sorry, but talk. By definition, the harmonic mean is appropriate for situation when the average of race is desired. A race is an average itself, is a ratio, the 1 over something or 2 over something. And you remember for HM definition there was everything is inverses. Okay, they call Painvisky reciprocal or like inverse 1 over 2. Okay? So it is used for that. How? Let us take now the category of not quantity, but relation. Relation. Prosti. And we remember that a number is an amount of place. We have seen that in arithmetic mean. And we have now to specify what kind of relation we have in mind with respect to the numbers adin and divit. So what kind of relation between these two numbers? If we only consider the category of quantity, we will only be able to say that divit is a bigger quantity than adin. In order to talk about relation, we have to be able to say, for example, how much bigger, in which way they are bigger, in terms of proportion, so ratio, 2/3, 1/3. It's Thales also, Thales theorem. With respect to one, equality of proportions, indeed, is what the Greeks thought about harmony, the Parthenon, the proportion, this over this, this over this, the equality of proportion, Thales theorem. You remember Thales, right? Thales theorem. There are two important theorems, Pythagoras and Thales. This over this equals this over this, etc. That. Harmony. Very important word for this. In order to introduce the idea of harmonic justice, not arithmetic justice, but now harmonic justice, in terms of the category of relation. Let us say that the medium term between adin and divit is at number h like harmony. Okay, here. Defined in such a way that the relative increase from adin to the medium term h must be equal to the relative decrease. So increase, must be equal to the relative decrease from dv to the medium term h. So there is a rate, it's like a ratio, it's like a percentage, if you want. It's like a percentage. The proportion, percent. Percent is from 0 to 100. 30%, but 30% is 30 divided by 100. So that means it is 3/10. And 3/10, so it's number between null and adin. So probability. It's related. And so the medium term, so here you can see. Okay. The medium term is the number h. So how to, you see h here is not h is not had a half. Okay. So it's but it's a mean, but another mean. How? Explanation is given here. Yes, it's given here better. Okay, here better. The medium term is a number h. Its relation to adin is given by the fact that there is a rate of increase. So we want to increase adin and to decrease divit. Before arithmetic, we gave to adin and we took from divit. But now we want to increase adin. How? Such as that. Big H, H, big Balshoi H, H, eta adin. So I start from adin, I multiply it by a rate. So eta adin plus malinka H. Malinka H is the rate. On the other hand, for divit, its relation to divit is given by the fact that the same rate, malinka H, is now the rate of decrease from 9 to H. That is, H equal from divit multiply the rate, but it will be adin minus because it is decrease. And now, in order to find the just number H that harmoniously equilibrates the difference between adin and divit, we first have to find out the common rate malinka H. This is given by applying this concept of harmonic justice to adin and divit. In other words, since by definition big H equal adin multiply adin plus H, and big H equal David multiply adin minus H. We have to solve the equation. Okay, we have to solve this equation for Malinka H. Once Malinka H is found, we just substitute it into the expression big H. Okay, it must be clear if we are substituting the expression, the other expression of big H, we will get the same result, of course. So the solution is this one. Okay. So why do I put like this? Because now, once we found that the medium term is equal to this. So we have small h, but we want to find big h. So we put inside big H the formula here. Okay? And now we found this. Okay? Why? How? Because you substitute. But you see, you have it is adin plus Malinka H. So how to find this? Well, this is so like that you have adin plus Malinka H. Adin plus okay, adin plus 9 minus adin 9 plus adin, da? Eta 9 plus adin over 9 plus adin plus 9 minus David minus adin over David plus adin. Это хорошо? Okay, I replace. Okay, so in the scholar. So eta David plus David into David plus adin. Это хорошо? Да? И потом, how can I obtain this? I divide everything by David. So eta 9 divided by David plus David divided by David over David divided by David plus adin divided by David. Eta adin plus adin divided by adin over adin plus adin over David. Eta 2 over adin plus adin over David. So I found good результат. But почему they write like this? Почему нет 2 over so adin, so adin plus ça fait 9, 10 over 9, so это 18 over 10. So это 1.8. Но почему нет? Почему like this? Потому что this is это harmonic. Это harmonic mean between Adin and David. Why? Look now the formula of harmonic. You remember? Here. For two numbers n equal 2, so 2, number x1 is Adin, number x1 is David. And you exactly the same formula. Okay. So it is called harmonic mean. Okay, harmonic mean. Это хорошо. So notice that h equal adin 0.8. The change from adin to h corresponds to an increase of 18%. This is the value h, 0.8, which compares with the decrease of 18%. The harmonic means corrects excessiveness of David over adin by means of redistribution according to proportion. Not strict equality, but proportion. Pythagoras expressed also this concept of harmonic justice in relation with system of musical tuning and the proportion of musical harmonic. You can find that information. I finish now very soon 2 pages with the last one, harmonic geometric mean. Okay. But before, I have to say, the mathematician and philosopher Leibniz, 17th century, transposed his definition of equality from the realm of logic, he was a very important creator of logic, into the concept of justice. There is legal, he wrote, there is legal equality between two individuals. If one individual being accused in a legal process with respect to a crime committed under some circumstance can be substituted by another, also an accused who committed the same crime under the same circumstance, without any change in the legal process. So it's like commuting, because the important word here is circumstance. But no, by taking account the circumstances of a crime, this definition of legal equality cannot be simply identified to the rules of commutative justice. It's not only changing, permuting. Why? Which are based on the strict arithmetic equality between individuals. Neither be restricted to the simplest principle of retributive justice. This is from Aristotelian, who write for the first time these words of different justice. Retributive justice is like, eye for an eye, okay. The next one is. Indeed, the definition from Leibniz allows the application of the principles of distributive justice, which are based on what Aristotle called a geometric equality, analogy. Initiated by Aristotle, this theory of justice was also praised by the French philosopher Jean Bodin, 16th century, and will be redefined by the American philosopher John Rawls in 1971. So it is philosophy. Now, application, well, it comes from that. So this notion of justice comes from Pythagorean means. Here, let us take finally the category now of quality. We have seen quantity, we have seen relation, now quality. Poion. Da? Poion. Any two numbers a and b allows us to conceive geometric figures called rectangles. Da? For example, from the numbers Adin and Yevit, we can think of the rectangle with side Adin and Yevit. Okay? To the Greek mind, asymmetry not beautiful. Okay. Not beautiful and also not just. It's not justice. Very bad. Not only very ugly, but also very bad. Among rectangles, we have to find that particular form which equilibrates the ugly rectangle above to a more beautiful representative figure. In the realm of rectangles, the most beautiful figure is the square, harmonious, since all its sides are equal. In order to move from the rectangle above to the square, we have to take away from the bigger number, David again, to take, somehow give more to the smallest number. But how? Until the point where both find justice. We have same. It's not mean equal necessarily, but like before, like proportionally, but now something different. The point of quality, of beauty. How? Until the point where both find justice in this redistribution. Since we fix the category of quality, and particularly the form of rectangles, we have to find the square that equilibrates Adin and Yevit, and to do that, we have to realize something that is equal to both, a common geometric denominator, something common to the both figures. What is? But this is the area. It is always like that, mathematics. When you have a problem, we have to take the upper side. And Gödel spoke about this in Logic. This will be the area of the rectangle. And because of the upper side, you can solve the problem. The area of the ugly and unjust rectangle is Adin multiply Dv. Eta Dv. The area of the beautiful and just square of side J is J multiply J. Eta J square. In other words, J square equal the same area. Adin multiply Dv. Eta Dv. Hence, Dv eta this. Okay? Well, this is a long story because it comes from Euclid. But the Pythagoreans is not come from Euclid because Pythagoreans knew that. So Pythagoreans is 2 centuries before Euclid. So Euclid was a student, etc. And then he wrote in a map. This is exactly This is exactly the geometric mean. Why? You remember, geometric mean, root square power n, but n equals 2, so root square 2 is root square, and 2 multiply, and must be positive, so the absolute value, they are positive. It's okay, I don't go back to show, okay? So it is geometric mean between, meaning the square root of the product is substitute the two numbers add-in and divide that form the English just rectangle by a single number j equal to r, single, that gives form to the beautiful and just rectangle figure that equilibrates those number add-in and divide the square of side j equal 3. Here is the form of qualitatively beautiful and just, qualitatively ugly and unjust. We have this in mathematics, in theory of information, and with entropy and everything. The order and the disorder. The pièce minute. The geometric mean equilibrates add-in and divide by taking away from the bigger number divide and giving to the smaller add-in in such a way that this redistribution makes them reach perfect beauty. Says as a conclusion. Хорошо? Заключение. Заключение. So this conclusion is a little bit I've done this morning. Piask časa na utra. So aš pat čut because I was thinking, how can I express? I want to express something for future, and I don't know. You will maybe question. By giving birth to the very concept of mathematics, Pythagorean philosophy signed the very foundation of European, and so Russian, of course, civilization. Behind every mathematical formulation, because Russia is in Europe formula, behind every mathematical formulation, until Ural, empire, Tsar. Behind every mathematical formulation, there is a Pythagorean philosophical background which had connected mathematics and humanities. So, first of all, this is maybe a problem for some, but I show that no, it's no problem. It's a historical fact. Mathematics was defined by Pythagoras as a symbolic expression of the creator of the visible and invisible world. The état fact, he has written. I found document on the internet. Defining nowadays mathematics as a science of relations between abstract entities, this is a definition of model, or the same by another mathematician, Polche, a very important mathematician, Stefan Banach, very important mathematician of 20th century in functional analysis. He said, mathematics is the science of analogies between analogies. Is another expression of the metaphysical research of what they called before mathesis universalis. Mathesis is Greek word, universalis is Latin. So the expression is a kind of universal knowledge, which would unite again, like before, not today, but Buddhist, mathematics and humanities. My dream. By separating mathematics from humanities and humanities from mathematics, we prevent students from really understanding science and humanities in a sense. I think, maybe you can debate. I think also a true education is based on these sacred islands between mathematics and humanities. That, I think, better sure. Спасибо.
Спасибо.
So if you have questions, I don't know. Покушать. Спасибо. Я не знаю. вопрос, это хорошо, это все, спасибо большое. Я не знаю, это работает? Я не знаю.